Okay, let's wrap up section 6 by looking at some of the tougher equations to solve. And that doesn't mean you can't do it. It just means you just have to use different steps. And it's going to get dirty with the calculator because, life isn't all pretty now, is it? Anyway, here are a couple of log equations, but you'll notice that you do not have log of something equals log of something else. So that's off the table. We don't have that going on. What we have is a log of something, in this case right here, is equal to a number, or in this case, a couple of logs added together is equal to a number. And so what do you do when you have that situation? And the answer, when you have a logarithm isolated, so this is actually pretty sweet. This guy's going to work right away. We write it in equivalent, this is what I do, exponential form, okay? So think about writing it in equivalent exponential form. And that's the thing where you go, the base to a power, what's the base? 4 to something equals something else. That's right, I follow this pattern. I go 4 to that guy equals that. 4 to the third, that's not a third, 4 to the third is equal to 3x plus 7. Well, that's not a hard equation to solve at all. It's not hard. All you have to do is go 4 to the third. Calculator tells you, hey man, that's 64. And I think everybody under the sun in our class right now can solve this. Subtract 7 to get what is that? 57 is 3x. And divide by 3, I actually think it goes in, doesn't it? Doesn't it go in 19 times? It does. So the answer to this is 19. Like I said, and I didn't emphasize it in the previous video, you do have to watch out for when you plug in. And it's good to actually see this. So watch this. If I want to check this, it says log base 4 of 3 times whatever plus 7, is that equal to 3? The number we got was 19. So what we get is log base 4 of 3 times 19 is 57 plus 7. Is that equal to 3? So log base 4 of 64, is that equal to 3? And the answer is yes, because 4 to the 3 indeed is 64. Okay, I just wanted to check one of them. There you go, it works. Sometimes when you get an answer though, you have to reject it, because when you plug it in, it goes log of a -2 and it goes, that's not defined. That may or may not happen in this next one. So help me with this one. What do you think about the first move, the very first move on this guy? And some of you might get this because we did it on the last video. Look, I mean, boom, property number 1. Put those two together, baby. Put them together. So we do. We write it as 1 logarithm. Is there a point to that? Yes. Because with 2 logarithms, I cannot do what I did on this previous example. But if I mush them together, I can write it in equivalent exponential form. And that is the ticket out of here with some of the tougher log equations. If I've got log equals number, this is good for log base A of a number or whatever is equal to, R, leads us to say A to the R equals M, and then we can solve. That's the game with the log equations. If it's not log equals log like this, like we did on the previous video, then you're going to get one logarithm isolated so you can write it in exponential form and get rid of the logarithm. You notice when we did this, we had a logarithm and now she's a gone. And that's the thing about it. Write it in exponential and there's no more logarithm. You're free. It's nothing but numbers and variables and you can solve. We're going to do it here too. But the first move is put it together with a property. So it's going to be bracket y times y minus 7. It's multiply because it's plus, right? It's property 1 is equal to 3. So I have a logarithm of something equals a number, and here it comes. The equivalent exponential form. That gets the logarithm out of the picture. It becomes 2 to the 3 equals the stuff. So 2 to the 3 equals y times y minus 7. Okay? That's our new equation. That's it. Do we know how to solve it? How about if on the left-hand side, I call that an 8? Is your brain thinking you know how to solve it yet? How about we multiply out on the other side? Yeah, there's a few moans in the audience now. Bring the 8 over. Because what we're recognizing is a quadratic equation. ZFS, baby, zero factor solve from a while back. So we have, what, y minus 8 and y plus 1. The answers are y is 8 or negative 1. Okay, just to show you, you take this guy up and you go, I've got log base 2 of y. I'm going to check this, plus log base, let me write this in the other color. So the original equation said log base 2 of y plus log base 2 of y minus 7 is 3. You can plug 8 in. It's not a problem because it's log base 2 of 8 plus log base 2 of 8 minus 7 is 1. That's all defined. But when you plug in minus 1, you have a problem. Log base 2 of minus 1 is not defined. So I cannot, by rights, plug in minus 1 into the original equation. So therefore, technically, legally, it's not a solution. We have to reject, so I'm going to say it in English, reject negative 1 as an answer, since log base 2 of minus 1 is not defined. I can't even plug it in. So the answer really is just 8. So this is, with exponentials, you don't have to worry about this. If you do your math right, you got the right answer. But with logarithms, you do have to wonder about, does it cause a problem? I personally give this, if you don't check it, I ding you a point or two max, but probably just 1. I know other teachers that will go, and take off a number of points, and I find it to be a little overreacting, okay? So anyway, that's how you do a couple of the stranger logarithmic equations. It's not terrible. This is about as, about the level of challenge we're going to see with logarithmic equations. On to the exponentials, shall we? Okay. On the next page, the exponentials, how many did I give? Just 2, good. And then at the very end, I have one of the applications, and that'll be it for this video. Okay. For the exponentials, what we're used to doing is, 5 to the x is equal to 5 to the negative 2, so x equals negative 2, everybody's happy. That's not happening here because on the other side here, I've got 5 to the x on one side, but the other side is 12. And 12, last time I checked, is not a power of 5. What do? Well, some people might read as they do these things, they take they write it in log form. And then they use something called the change of base formula, which I have not covered. Okay, I forget where that is, but let's say we don't know the change of base formula. What I do is I think of being a fireman with a ladder or a log, let's say, a woodsman, and I have a kitten stuck in a tree. I've got this equation, and X is meowing. He's up there at the top of the 5 tree, and he goes, help, help, help. I'm going to go get myself a log, and I'm going to lean it against the tree and let the cat crawl down. Isn't that silly to say? So I've got meow, meow, and I'm going to get a log, and this X is going to crawl down. The only way to do that is to really use a log, which is a logarithm. And so that's the big move here. Here's our equation again. 5 to the x equals 12. And I come sweeping in here, and I use one of 2 logarithms, which I think I'll just say, why don't you just use log? The next section will require taking the ln instead, is easier. But we're going to log both sides of the equation. The numbers are equal, therefore their logs are equal. If the logs are equal, the numbers are equal. That's from the last video, okay? What does this allow us to do? Well, it's property, baby. It's property 3. Property 3 says a power inside can crawl down the log like a kitten out of a tree, and you have the following. You have x times log 5 is equal to log 12. Now, pause. Log 5, I'm saying log 5, that's how I talk in math. But what it really is x times the logarithm of 5, it's a number, equals the logarithm of 12. So whatever x is, it multiplies with the logarithm of 5 and it becomes logarithm of 12. Think of this as an equation that says x times 2 is equal to 14. How would you solve it? You would divide by 2. Likewise, what we're going to do is, in this case, divide by what? Log 5. Okay. So, in the old days before calculators, and I'm barely at the cusp there, we would write x equals log 12 divided by log 5. My brother, who's older than I am by about 7 years, had to whip out a slide rule in engineering school, believe it or not. And then he got a calculator in the midst of his career at Long Beach State. We whip out the calculator and we simply go, well, you type in this on the calculator, hit the log button, gives you a parentheses, put 12, close paren, divide, hit the log button, parentheses, put in a 5, close parentheses. That's how it's done. Let's do it. So log 12 divided by log 5 is, I'm getting about a 1.54. I think I'll round it off there. So it's about, this is about 1.54. Okay, in my math lab, they'll tell you how to round. So watch out for that and be sure you get it right. So that's interesting. Look at the table. 5 to the 0 is 1. 5 to the 1 is 5. 5 to the 2 is 25. What we just figured out is that 5 to the about 1.54, and you can check this, is 12-ish, okay? You can check it right now. Do 5 up caret 1.54, and it'll be 11.99 something or other. It'll be really close. We're not going to get an exact answer because it's actually an irrational result. It just goes on irrationally. All right, this next one is a little more messy. Let's take this one on. Okay, so once again, we have kittens in a tree, this time 2 of them, but that's okay. What we're going to do is once again use logs to get them out of the tree. So we are going to log, by the way, we're using log base 10. That's on the calculator, right? That's what we just did. This allows our kittens to come out of the tree. So this guy's a multi-legged one. He's going to crawl out. This is property 3. This one's going to crawl out like the previous example. And let's write what we've got. Here's a mistake. Ready? Here's a mistake. X plus 1 log 7 equals x log 4. Okay, if you got this far, you're doing great. You're about a B student right now, or B or C student. But for the A to happen, that guy with multi-legs has to multiply. You got to multiply both those guys by log 7. That's all. So again, think of this as saying, oh, it's x plus 1 times 2 is equal to x times 5. How do I solve that? Well, normally you distribute, and we do the same thing here. We're going to do the same thing here. We are going to distribute the log 7, and of course, we'll stop right there. So what do we get? We get x times log 7, logarithm of 7, plus log 7 is equal to x log 4. Now, this is where it gets kind of stinky because you have 2 x's, okay? I'm going to do the following. I'm going to subtract x log 7 from this side, and it appears over here as minus x log 7. And the reason is I'm getting x's on one side, okay? You'll see why in a moment. So this guy's gone, and you're left with log 7. And this is a good problem, man, I'm telling you, is x log 4, x times log 4 minus x times log 7. Okay, at this point I say, what's the next move? And there might be a student that's paying attention and knowing it would say, I think you did it right. You factor out the x. That unlocks it for the a, all right, for you guys. And the last step, divide this guy over. A lot of times people get really confused on this, and I give them a bit of a crutch. I just go, if you cannot handle or can't stand these logarithms and don't understand what's happening, what you could do at the front end, like right here and here, is actually compute log 7. You go, okay, so for instance, log 7 is 0.845. And so a student would go, I'm going to go with 0.845. And then log 4 is something else. And then they just use decimals, and they can get a close answer. Typically, they're a little bit off and they lose a point, but at least they see the numbers without the logarithms making them crazy. But if you can handle the logarithms, here's your calculation. X is take the log of 7 and divide it by the log of the difference between the log 4 and log 7 to get your answer. On a calculator, I would write, I'd punch the buttons to go log 7. It gives you a paren, put 7, close it, so, and then divide, and then use a paren for the denom. Hit log again, it has a paren, put in 4, close it, minus, hit log again, paren, put in a 7, close it, and then close the denominator. And then hit equal. And that's what I'm going to do right now. Okay, so log 7. Let's see, log 7. I should have done these numbers right. Divided by parentheses, log 4 minus log 7, close, close. And we're getting a negative, roughly negative 3.477. So I'll say x is approximately negative 3.48. Now, if you want to play around and check that thing, you can. You would go to the top here and plug those numbers in to see if the two sides equal each other. Pretty good problem. We found them where they actually cross. In college algebra, they actually have you graph y is equal to 7 to the x plus 1, and then y is equal to 4 to the x. And you're going to have two exponentials, and where they cross is the winning answer. Okay, in this case, it looks like it's negative, so they're back here somewhere where they finally cross. It's interesting stuff. Okay, so I'm going to round this out. This is our last problem on this video, and this is going to be an application. It's actually pretty straightforward. You guys that are afraid of applications, you really shouldn't. You should just read this thing and go, some are hard and you don't like doing them, but others, in this chapter in particular, they give you a formula for you to mess around with. So that's not so terrible. And also the formula about finding the max and min. A formula oftentimes is given to you and you just basically goof with it. So you should get, buck up a little on that. Watch this one. The amount A of 70 grams of a certain radioactive material remaining after T years can be determined by this equation. Okay. When will 10 grams remain? Yeah, you gotta think. What's A? What's T? What does it mean, when will? I stole this right out of the book, so I really don't like his language. I'd say, I would probably help you out and go, in how many years? Is what I would put there to help you guys out. This is what we all want you to understand. You're studying algebra. You're learning about functions. Functions do this. They relate one variable, A, to another, T. So here's T, pretend that's X, and here's A, and you have a table of values anytime you want. And they're saying, when will, or how many years will it take until there is only 10 grams remaining? So the amount A is here, and the question is, what the heck is T? That's what you want to be able to do. That's the thinking you have to do. Then you take down this formula. Is that just T? Yes, T. And you come along and you replace A with what? 10. I see I need to teach you a little tiny bit about solving equations, exponential equations. But this is really cool because what we're learning is radioactive decay on this one. How long does it take for the amount to go from 70 grams of stuff to where it's only 10 grams? How long does it take for all the rest of it to decay? Okay, there's one thing to teach you that you would probably maybe mess up, most people do, is I want to get it in exponential form. So I want to get it in like 0.62t is equal to something. And then I'm going to log to get Kitty out of the tree like we were doing before. But someone's in the way. Yeah, the 70, once I spell it out to you, you see it, don't you? The 70's in the way. You see the plan, I'm the teacher, I'm guiding you. Look, I want to get it in exponential form so that I can get the kitty out of the tree. So the 70's in the way, and you saw what I did just there. Divide by 70, I'll just write it as 1/7, leave it alone. And we've got this. Like that. All right, let me move them over, because what's the next move, everybody? Get Kitty out of the tree. I got to log both sides to make that happen. And watch property 3 happen. This guy's going to crawl down out of the tree. So we have log of 1/7, I don't care what that is equal to t times log of 0.62. How do I get t alone? Divide both sides. And it's a cool operation, but look, man, we're figuring out how, we're scientists. It's amazing. What we're going to do is I'm going to type in log of 1/7. So I'm going to go log 1 divide 7, close parentheses, divide log, and then 0.62. Close. And I got about a 4.07. So roughly, I'll say roughly 4.1 what? Look up here, years. So the radioactive decay, to get it from 70 down to 10, will take about a little over 4 years for it to decay downward. You know, you're looking at these nuclear reactors they've got radioactive material in Japan, Chernobyl, different places, and they're just waiting for it to decay. It could take a long time. That's the trouble, okay? Anyway, that's it for this video. Enjoy the homework.